In the summer of 1992, a highway construction crew in Missouri hit a problem nobody had planned for. A 300-year-old Bur Oak, 8 feet across at the base, roots running 12 feet down and 40 feet in every direction, refused to move. Their $285,000 Caterpillar excavator bent its hydraulic arm trying. A specialized drill rig sank into the clay. 11 days in, the engineers still had no answer. So they drove 2 miles up a county road and knocked on the door of a 75-year-old farmer named Eugene Pratt. He owned a steam engine from 1912. Nobody on that crew understood what they were about to watch. Linn County, Missouri summer, 1992. There is a particular quality to Missouri heat in late June that has nothing in common with the honest, dry warmth of the plains to the west. It arrives heavy and wet, carrying the smell of river clay and cut grass, and something older, something that belongs to the black loam of the bottomlands, where oak trees have been measuring the passage of centuries by the width of a single growth ring. By the summer of 1992, the stretch of tree line running parallel to State Route 11 east of Brookfield had been standing since before anyone in Linn County could trace their family name back through written records. The big Bur Oaks along that corridor, the ones with bark so deeply furrowed it looked like the surface of a dry creek bed, had been there when the first settlers arrived with their ox teams and their iron plows. They had been there during the Civil War, when this part of Missouri was a border country of burning barns and midnight raids. They had been there through every drought and flood and ice storm that the Missouri River Valley had thrown at them. And in the summer of 1992, they stood in the path of a 4-lane highway expansion that the Missouri Department of Transportation had been planning since 1988. The man who would ultimately decide the fate of that project's most stubborn obstacle was not an engineer. He held no degree from any university. He had never operated a computer. And when the Kansas City engineers arrived on his property line in their white pickup trucks with their laptops and their laminated site maps, Eugene Pratt watched them from his porch swing with the same unreadable expression he wore when he watched the weather. He was 75 years old. He had been farming this part of Linn County since he came home from the Pacific in 1945 with a shrapnel scar on his left shoulder and a mechanical education that no school in Missouri was offering at the time. 4 years of watching Navy machinists keep destroyers, running in conditions that would have made a factory foreman weep. But before the Navy, and more important than the Navy, there had been his grandfather. And before his grandfather, there had been the machine. The J.I. Case Company of Racine, Wisconsin, built their 80-horsepower steam traction engine for the last time in 1924, having first produced the model in the late 19th century through successive refinements that culminated in what the company's own catalog called the most powerful agricultural prime mover available to the American farmer. The machine that Eugene Pratt owned, the one his grandfather, Harlan Pratt, had purchased in the spring of 1913 for the sum of $840, a price that represented roughly 3 years of clear profit from a working farm, was a 1912 model. Serial number 27,441, finished in Case's characteristic dark green with red wheel trim that had long since faded to the color of old brick. It weighed, when fully loaded with water in its boiler and coal in its bunker, approximately 28,000 pounds. Its rear drive wheels measured 7 feet in diameter and were fitted with steel cleats, grousers, in the language of the trade that were originally designed to bite into soft prairie soil during threshing season. Its front steering wheels, smaller and narrow, were linked by a chain and sprocket system to a cast-iron steering wheel in the operator's position, though steering was a generous term for a machine that required approximately 40 feet to execute a full turn at its maximum operating speed of 3 miles per hour. Its boiler, fired by either coal or wood, was rated to generate steam at 150 pounds per square inch, and that steam, routed through a two-cylinder single-expansion engine mounted crossways on the boiler barrel, could produce a drawbar pull that no one in 1912 had ever measured precisely, but that every man who had operated one described, in the specific vocabulary of working farmers, as enough to pull the world sideways if you had something to hook into. Linn Pratt had used it for 30 years on the family's 480 acres, threshing, breaking virgin ground, pulling stumps during the clearing of the North Field, which had taken 3 summers in the 1920s. When Linn died in 1941, the machine passed to his son, Wallace Pratt, who used it for 7 more years, and then parked it in the west end of the old granary, when a neighbor sold him a Farmel M for $600, and the age of internal combustion rendered steam obsolete in everything but sentiment and memory. Eugene inherited it along with the farm in 1962, and unlike every neighbor, every implement dealer, and every Farm Bureau representative who had suggested over the subsequent 3 decades that he ought to sell the old thing for scrap at its weight, it represented several $1,000s of raw steel he had kept it running. Not running in the sense of operational, exactly, but running in the sense that its boiler was intact, its valves reground, its piston rings replaced with parts machined at a shop in Chillicothe, and its firebox re-bricked in 1978 by a retired locomotive mechanic named Odell Castleberry, who had done the job for 2 cases of Pabst Blue Ribbon and the satisfaction of working on something that predated everything he hated about the modern world. Each September, during the county fair's antique machinery demonstration, Eugene fired up the old case and drove it the 4 miles from his farm to the fairgrounds. The process of raising steam from a cold boiler took approximately 90 minutes. He began at 4:30 in the morning, alone in the granary with a kerosene lantern, feeding coal into the firebox from the bunker that sat behind the boiler on the tender deck, watching the pressure gauge climb from 0 to the operating range of 130 to 150 pounds per square inches, while the sky outside went from black to gray to the particular luminous pink that preceded summer sunrises in north-central Missouri. By the time he rolled out of the equipment shed door, the sun was fully up and the steam was exhausting in rhythmic white puffs from the stack that rose above the boiler, and his neighbors came out to their driveways to watch him pass, because there was no other sound in Linn County quite like the sound of that machine working a deep, metronomic chuffing that you felt in your sternum before you heard it with your ears. People called it the Iron Dinosaur. They meant it affectionately, mostly. Mike Renner had been in highway construction for 18 years when Mid-States Construction won the contract for the State Route 11 expansion in the spring of 1991. He was 42 years old, compact and precise in the way that men who manage large construction crews tend to become economical of motion, quick with numbers, accustomed to solving problems by the application of sufficient capital and equipment. He had managed projects in 4 states. He had supervised the clearing of a 100-acre site in Kansas that had required removing 47 mature trees over the course of 2 weeks. He drove a company pickup that still smelled of new plastic, and he kept a roll of survey flagging in the door pocket for the instinctive habit of marking things that needed attention. When he arrived at the State Route 11 site in June of 1992 with his lead equipment, a Caterpillar 330L hydraulic excavator that had been delivered new from the dealer in Kansas City at a purchase price of $285,000, he had every reason to believe the timeline was straightforward. Clear the tree line on the north side of the existing road, extend the drainage culverts, grade the subbase, and have the gravel underlayment poured before the fall rains made the clay subsoil impossible to work. The trees along the right-of-way were mostly secondary growth, ash and elm and hackberry that had come up in the decades since the original forest had been selectively logged. They were big enough to require equipment but not exceptional. His operator, a 28-year-old named Dale Ferris, who had been running cat machines for 6 years, could drop and clear a mature elm in 20 minutes. He cleared 19 trees in the first 2 days. On the 3rd day, Ferris drove the 330L to the northeast corner of the cleared zone and encountered the Bur Oak. To understand what a 300-year-old Bur Oak means, structurally, it helps to understand what the species has been designed by 300 million years of evolution to do. Bur Oak Quercus macrocarpa is the dominant tree of the prairie forest edge across the upper Midwest for a very specific reason. It is the most fire-resistant, drought-resistant, and mechanically stubborn tree in its range. Its bark, at maturity, is thick enough to insulate the cambium layer from grassland fires that kill every other competing species. Its acorns are enclosed in fringed cups that protect them through extreme weather. And its root system is not merely extensive, it is architecturally aggressive in a way that no other oak matches. A young Bur Oak seedling, at the end of its first growing season, may stand only 8 to 12 inches above ground, while its taproot has already penetrated 4 feet into the earth, and its lateral roots have spread 2 feet in every direction. The ratio of below-ground to above-ground biomass in a mature specimen can be as high as 3 to 1. A tree that stands 60 feet tall with a trunk diameter of 30 inches at chest height, what a forester would call a standard Bur Oak, may have a root system that penetrates 12 to 15 feet deep at the taproot, with major lateral roots extending 40 feet or more from the trunk base at depths ranging from 2 feet to 6 feet below the surface. These lateral roots are not the fine, fibrous feeder roots of shallow-rooted species. They are structural roots, woody, rigid, often 8 to 12 inches in diameter themselves, that interlock with the surrounding soil matrix in a way that effectively fuses the root plate to the surrounding ground. The Bur Oak at the northeast corner of the State Route 11 clearance zone was not a standard specimen. It was exceptional in the specific geological sense of the word. Exceptional as a sandstone formation is exceptional, as a particular bend in a river is exceptional, because it had survived long enough to become something that its younger counterparts were not. Its trunk was 8 feet in diameter at ground level, measured by Dale Ferris, with a tape measure at Mike Renner's direction on the morning of June 17, 1992, and flared outward at the base into buttress roots that surfaced from the ground like the knees of a cypress, running out from the trunk in 5 distinct directions before submerging again. Its canopy covered an area approximately 90 feet in diameter. The bark on its lower trunk was furrowed to a depth of 3 inches, and the furrows had accumulated decades of moss and lichen and the paper-thin nests of mud dauber wasps. The tree's crown, viewed from a distance, had the rounded, asymmetric shape of something that had responded to wind and competition over centuries, adding wood in the directions where it was needed and withholding it where the pressure was absent. County records, a survey map from 1887, held at the Linn County Courthouse, listed it as a corner witness tree, meaning it had been used as a fixed reference point by the original land surveyors, because it was already so large and obviously permanent that its location could be trusted as a stable geographic marker. That notation placed the tree's approximate age, at the time of the 1887 survey, as not less than 180 years. By 1992, it was close to 300 years old. Dale Ferris brought the 330L's bucket against the northeast face of the root system at 9:14 inches the morning on June 17th. He was confident. The machine weighed 71,000 pounds and could exert a digging force of 50,000 pounds through its bucket cylinder. He had pulled stumps of 30-inch elms in 10 minutes. He began by attacking the largest surface root, a lateral running northeast from the trunk at approximately 14 inches of diameter, and drove the bucket teeth into the junction between root and soil. The root moved slightly. The bucket teeth skidded. He repositioned and tried from above, using the arm's downward force to break the root at a midpoint. The bucket bent at the lip slightly, the sheet metal deforming from the impact, but the root did not fracture. He spent the rest of the morning working around the root system's perimeter, breaking smaller feeder roots, loosening the soil matrix, trying to isolate the major structural roots from the surrounding ground before committing full force to a pull. By noon, he had broken 2 secondary roots and excavated a trench approximately 3 feet deep around a 20-foot arc of the route's northeastern sector. At 1:30 inches the afternoon, he brought the arm around for a direct pull against a primary lateral root running directly east. The hydraulic cylinder connecting the boom to the stick, the first in a series of 3 hydraulic actuators that constituted the excavator's arm system, failed at 2:17 p.m. The cylinder rod did not crack. It bent, plastically deforming at a 0.6 inches from the barrel end, where the metal had been stressed repeatedly by the lateral loading of the afternoon's work. The arm dropped to its mechanical stop. Ferris shut the machine down and sat in the cab for a moment, looking at the Bur Oak through the glass, before calling Mike Renner on the radio. Renner drove out from the field office trailer in his pickup. He stood with Ferris for a few minutes, looking at the tree, then at the excavator's arm, then at the tree again. "Get me the service number for the cat dealer in Kirksville," he said. The replacement cylinder arrived 2 days later, brought out by a field service truck from the dealer. The repair took most of a day. While it was being done, Renner walked the project timeline backward from his deadline and found that he had lost 7 effective working days to the oak stump problem, 5 days of equipment sitting idle, pending repair, plus the 2 days of failed excavation work that had accomplished nothing. He had a contractual completion milestone for the clearing phase that he was now at risk of missing. He called his project engineer, a recent graduate of Kansas State University's civil engineering program, named Brad Howell, and asked for an assessment. Howell's recommended solution was to bring in a hydraulic drill rig to fracture the root system at key nodes before attempting extraction. The rig would cut cylindrical holes at 3-foot intervals around the root perimeter, effectively pre-cracking the root plate along planned fracture lines that could then be exploited by the excavator. Renner approved the plan on July 2nd and arranged for the drill rig to be trucked in from a geotechnical contractor in Columbia. The drill rig arrived on July 5th, a Saturday. It was a Bauer BG-12H, a machine designed for installing driven piles in urban construction, adapted with a rock auger bit for the fracturing application Howell had specified. The operator, a man named Curtis Blaine, who had been drilling geotechnical borings for 12 years, examined the site, probed the soil, and made the same observation that the rain had created. The clay was saturated to a depth of at least 4 feet, and the auger bit was not going to achieve the purchase it needed to transmit torque into the root matrix. On his first attempt, at approximately 11 o'clock on the morning of July 6th, the auger bit contacted a secondary root at 14 inches depth, and then, as it attempted to drill through, the reaction torque caused the drill mass to rotate approximately 15 degrees before the machine's torsion restraint system caught it. The bit had not penetrated the root. It had simply been deflected. On his second attempt, repositioned 2 feet to the north, the bit found a gap between roots and drilled successfully to 3 feet. On his third attempt, at a point on the south side of the root plate, the auger bit struck a primary lateral root, and the deflection was severe enough to throw the entire drill mast out of plumb, about 8 degrees of lean from vertical. And when Blaine retracted the bit and attempted to re-establish vertical alignment, he found that the track frame had sunk approximately 4 inches into the saturated clay. He spent the rest of the day extracting the drill rig from the mud. On July 7th, day 11 of the stump problem, Mike Renner sat in his field office trailer with Brad Howell and his superintendent, a veteran named Pete Salcedo, who had been building roads in Missouri for 22 years, and tried to find a solution that did not involve a third equipment failure and a second delay letter to MoDOT. It was Pete Salcedo who said it, with the particular flatness of a man who has observed something for a long time before deciding to mention it. "There's an old man farms about 2 miles north of here," Salcedo said. "He's got a steam tractor. 1,912, I think. He uses it for the county fair demonstration every September." He paused. "I've seen him pull stumps with it. He's got a rigging system." Renner looked at him. "A steam tractor. 80 horsepower. It's set up to pull, not to dig. And it's got wide tracks, those old rear wheels are wide. It doesn't sink. Renner was quiet for a moment. Then, do you know the man? I know who he is, Eugene Pratt. His property line is about a quarter-mile up the county road. Eugene Pratt answered the knock at his door at 6:40 on the evening of July 7th, wearing his work clothes, canvas trousers, and a plaid shirt with both front pockets, worn through, and listened to Mike Renner's explanation without changing his expression or offering the man a seat. When Renner finished, Eugene looked past him at the company pickup in the driveway, then back at Renner's face. "What exactly broke on your machine?" he asked. Renner described the hydraulic cylinder failure. Eugene nodded slowly. "Lateral load," Eugene said. "You were pulling sideways, and the cylinder was designed to push downward. That's not a failure. That's a misuse." Renner absorbed this without visibly reacting. He had been managing crews and clients and bureaucrats for 18 years, and he recognized the particular tone of a man who was about to tell you that you had made a mistake before deciding whether or not to help you fix it. "Can you remove the stump?" Renner asked. "I can probably loosen it to the point where your machine can pull it," Eugene said. "I can't promise to pull it clean by myself, but I can separate the root mass from the surrounding soil, which is what you've been failing to do." "How long would it take?" "Half a day if the clay cooperates. Maybe all day. I won't know until I see what the roots look like under the surface." "What would you charge?" Eugene thought about this. $200 and whatever fuel the boiler burns. I'll supply the coal. You supply the access I'll need to get the machine across your cleared zone, and I don't want to have to navigate around equipment." Renner thought about the fact that his project was 11 days behind schedule, and that his cost overrun from the failed excavation and the drill rig rental was already approaching $14,000. He extended his hand. Eugene did not shake it immediately. He looked at Renner with the direct, assessing gaze of a man who has evaluated livestock and weather and human character with the same instrument for most of his adult life. "Before I agree," Eugene said, "I want to understand something. Your engineers saw that tree and decided the right approach was to attack it. I want to know if you're willing to work a different way." "What way is that?" "Slow," Eugene said. "Patient. With the grain of the thing rather than against it." Renner waited. "My grandfather taught me a phrase," Eugene continued. "He used it every time someone wanted to force a machine problem. He said, 'You can't beat physics with muscle. You have to work with physics, not against it.' Your machine has been trying to overpower that root system for 11 days. I'm not going to do that. I'm going to work with it." He paused, looking out past Renner at the evening light on the corn. "If that bothers you," Eugene said, "then this won't work." "It doesn't bother me," Renner said. And he meant it, which surprised him slightly. Eugene shook his hand. He spent most of the next morning preparing. The preparation took 4 hours, and it was entirely invisible to the project crew, who had cleared a path for the steam tractor and then stood around the site trailer drinking coffee and waiting. Eugene worked in his granary with a methodical precision that bore no resemblance to urgency. He inspected every link in 3 lengths of 1-inch proof coil chain, 200 feet total, by running his fingers along each link and flexing the metal in his hands, feeling for the slight give of a stressed link that his eyes might miss. He inspected 4 cast-iron pulley blocks, each capable of handling a rated load of 6 tons, checking the sheave pins and the becket eyes and the shell rivets with a flashlight and a thin rod he used to probe for hairline cracks in the cast iron. He had built this rigging set himself over the course of many years, accumulating it piece by piece from farm sales and from the Sears Roebuck catalog and from a marine salvage yard in Street Louis he had visited in 1961, where he had found the large 8-inch sheave blocks at a price that still pleased him when he thought about it. The 4-pulley block and tackle system he was planning to deploy would give him a mechanical advantage of 8-to-1. In practical terms, this meant that the 28,000-pound machine, which could generate a drawbar pull at the drum of perhaps 12,000 pounds under sustained steam pressure, would translate that force through the pulley system into an effective pulling force of approximately 96,000 pounds at the working end of the chain. This was nearly double the breakout force the Cat 330L had been attempting to apply through direct mechanical action. But the difference was not just in the magnitude of force, it was in how that force would be applied. Slowly, steadily, without the shock loading that occurs when a large machine swings its arm in a sudden pulling motion and subjects the target and its own hydraulic cylinders to impact forces that can exceed the rated load by 2 to 3 times. His grandfather had explained this with a piece of baling wire in the kitchen. When Eugene was 9 years old, pressing the wire against the table edge at various angles and watching it flex. "You can break this wire a dozen ways," Linn Pratt had said. "You can yank it apart, and it takes about this much force." He snapped the wire with a sharp pull, but if you want to break it where you want it to break, slowly, with control, you don't yank. You bend it back and forth, right here, right where you want it. You work with the metal. You find the way it wants to fail and you guide it there. He had picked up 2 more pieces of wire. And if you want to move something that's too heavy to move, you don't add more muscle. You add more rope. You build leverage. Pulling 100 feet that's possible is always easier than pulling 40 feet that's impossible. That was the principle he had been applying since 1945. He had used it to move a 9,000-pound granite boulder from his south field, which had been deposited there by glacial action, and which his father had been plowing around for 40 years. He had used it to extract a wagon from a creek bed in 1958, when his neighbor Harold Kessler had driven too close to the bank and gone in. He had used it to clear the stumps of 6 large cottonwoods from the creek bottom in the wet spring of 1971, when every neighbor who tried to pull stumps with their tractors simply dug the machines deeper into the bottomland mud. The steam tractor's advantage was not its horsepower. Exactly. Its horsepower was substantial but not extraordinary by modern standards. Its advantage was that it produced that power at very low revolutions. The big flywheel turned at approximately 225 revolutions per minute under load, and the working speed of the drive wheels was such that the machine's drawbar pull was sustained and steady rather than pulsed and irregular. It could hold a load indefinitely, generating a constant, patient pressure that would maintain tension in a chain for minutes at a time without variation. Modern hydraulic machines were powerful, but they were also reactive. Their pressure systems responded to resistance, and when resistance exceeded a threshold, the system either relieved pressure through valves or transmitted the shock to structural components. This was why cylinders bent. Steam did not shock load. Steam simply pushed. He fired the boiler at 4:45 that morning, alone in the granary as always, feeding coal from the tender bunker into the firebox with a long-handled scoop shovel. He watched the pressure gauge on the front of the boiler jacket. Its needle moved from 0 to 20 pounds per square inches in the first 30 minutes, accelerating as the water in the boiler approached its boiling point and began generating steam. At 70 pounds per square inches, he could hear the first tentative sighing of the safety valve float the valve that would open and vent steam to the atmosphere if pressure exceeded 155 pounds per square inches, protecting the boiler from overpressure. He kept the firebox fed at a moderate rate, not trying to force the temperature, letting the thermodynamic process proceed at its own pace. At 6:15, with pressure reading 135 pounds per square inches, he engaged the throttle and drove the machine out of the granary into the morning light. The sound it made was exactly as it always was, a deep, chuffing exhale at each piston stroke, the steam exhausting through the stack in a rhythm that corresponded to the engine's RPM. Under no load, driving on the county road, the engine cycled at its governed speed and the exhaust puffs came quick and regular, like a heartbeat measured by something with a slower pulse than a human. When he crested the slight rise before the project site, he could see the cleared zone ahead, the pale slash of raw earth where the trees had been removed. The red clay subsoil exposed to the morning light, the yellow Cat 330L parked to the side with its arm lowered, and beyond it the Bur Oak, standing in the corner of the clearing like something that had decided not to move and had been winning the argument for 11 days. Several members of the construction crew were already there. Dale Ferris leaned against the Cat's track with his arms crossed. Brad Howell stood with his notebook. Pete Salcedo stood slightly apart, watching Eugene's approach with the quiet recognition of a man who knows something is about to happen that he can't quite explain to his younger colleagues. Mike Renner walked out to meet him as Eugene throttled back and eased the machine to a stop at the edge of the cleared zone. The steam exhaust slowed to a gentle sigh. The pressure gauge read 140 pounds per square inches. "Morning," Renner said, looking up at the machine. Standing beside it, he came to approximately the center of the rear wheel. The drive wheels were taller than he was. "Morning," Eugene said from the operator's platform. "I'll need a few hours to rig up before I start pulling. I want your excavator operator to stand by once the root breaks. I'll need him to remove the sections as I separate them. You try to take the whole thing at once and you're going to lose it." "Understood. I'm going to work from the perimeter inward," Eugene said. "The opposite of what you've been doing. You've been attacking the center, the main root ball, and trying to extract it whole. I'm going to detach the lateral roots from the outside in, reduce the anchor points, and then address the taproot last." Howell looked up from his notebook. "That would have been my approach as well, in retrospect," he said, which was more candor than most 24-year-old engineers were capable of. "It's the right approach for any stump," Eugene said without particular emphasis. "But it's especially right for one this old. The laterals are what's holding it. The taproot provides stability, but not the holding force. The laterals are where the resistance is." He climbed down from the operator's platform, moving with the careful deliberateness of a 75-year-old man, descending a large piece of iron in work boots, and went to the storage chest mounted on the tender deck. He began removing chain. The rigging took 2 hours and 40 minutes. He worked without hurry, talking occasionally to Salcedo, who helped him carry chain and hold pulley blocks while Eugene located his anchor points. He chose the anchor trees with care, 4 living oaks positioned outside the cleared zone that were large enough to hold his rigging loads without being pulled toward the stump, and he wrapped each anchor with a protective saddle of heavy canvas before running the chain around it, both to protect the anchor tree's bark and to prevent the chain from biting into the wood and reducing his effective anchor point. Around each saddle he ran a length of chain in a choker configuration, securing the chain end with a grab hook, and checking that the hook was seated against a full link rather than a partial bite. From each anchor point, he ran a length of chain to a cast iron pulley block. From the pulley block, a second chain ran back toward the Bur Oak, threading through a companion block that he attached to the root he was targeting. From the movable block at the root, a 4th run of chain led back to the fixed block, and then a final run led back to the drawbar of the steam tractor. This 4-sheave arrangement gave him a theoretical mechanical advantage of 8-to-1, reduced by friction in the sheaves and chain to an effective advantage of approximately 5-to-1. He set up this system at 4 separate points: northeast, northwest, southeast, and southwest, attacking the 4 primary lateral roots simultaneously rather than one at a time, distributing the extraction force around the circumference of the root plate. Ferris watched the rigging process with the focused attention of someone who is revising his prior assumptions in real time. "Why 4 rigs?" he asked, during a pause when Eugene was lubricating the sheave pins with a small can of linseed oil he carried in his shirt pocket. "Because the root plate is a structure," Eugene said, without looking up from the sheave. "It's held by anchors in every direction. If you pull from one direction, you're just pivoting the plate around the opposite anchor. You have to reduce all the anchors at once, or you get rotation instead of extraction. That's probably why your machine kept slipping. The root was pivoting, not pulling out." Ferris was quiet for a moment. "We lost 3 hours one afternoon to that. The stump was rotating around its base, and the bucket teeth kept losing purchase." "Yes," Eugene said. That's what it would do. He moved to the next sheave block. He began pulling at 9:40 a.m. He engaged the steam tractor's clutch slowly, allowing the chain to take tension before the machine's full drawbar force was applied. The chain runs tightened sequentially, the northeast rig first, pulling taut with a resonant harmonic hum as the chain links seated against each other under tension, then the northwest, then the southeast and southwest, as Eugene repositioned the machine and ran the chains through a central fair lead he had mounted on the front axle housing, allowing him to tension all 4 rigs from the single drawbar. The arrangement was not strictly correct. From a rigging standpoint, the forces were not perfectly balanced, but it was close enough, and it was the system his grandfather had used on similar stumps in the 1920s. The first indication that anything was happening came from the northeast lateral root, a quiet, sustained cracking, not the sharp snap of a root under sudden loading, but the long, tearing sound of something separating from the soil matrix gradually, fiber by fiber. A small mound of clay at the root's far end rose slightly, perhaps 2 inches, as the root's distal end began to be drawn upward. Then the crack propagated inward along the root's length, and a segment of the northeast lateral, approximately 12 feet from the trunk, 14 inches in diameter, lifted free of the soil on its upper surface, while its lower surface remained in contact. Eugene watched from the operator's platform, one hand on the throttle, monitoring the chain tensions by the sound they made. A chain under proper tension sings. A chain that is approaching its limit makes a different sound, a lower, more urgent vibration that experienced operators recognize as a warning. He had been listening to chains under load for 50 years. He knew the difference. He held the current load for 4 minutes, maintaining constant pressure, letting the tension do the work of separating root from soil rather than attempting to increase it. The sustained pressure allowed the clay to dewater slowly in the space around the root. The negative pore water pressure that had been holding the clay against the root surface released as water migrated away from the zone of tension, reducing the adhesion force that was keeping the root in place. At 10:04, the northeast lateral broke free of its soil anchor at a point approximately 18 feet from the trunk. The separation was not a single fracture but a progressive, peeling the root's outer surface, releasing from the clay first, then the inner portion following over the course of perhaps 30 seconds. The chain tension dropped slightly as the resistance was reduced, and Eugene throttled back to hold the extracted root segment in tension, while Ferris moved the cat in and severed the freed section with 3 quick bucket strikes. Then Eugene moved to the northwest rig and repeated the process. By noon, he had separated 2 complete lateral roots from the root plate and had substantially loosened a third. He stopped to eat a sandwich and drink water from a thermos. The crew watched him eat with the same uncertain attention they had given the rigging process, this combination of age, machinery, and patience that operated according to entirely different logic than anything in their experience. Brad Howell came over and sat on a chunk of tree trunk near Eugene. "The sustained loading," Howell said. "That's doing most of the work. The pore water pressure release, that's a soil mechanics principle. Consolidation theory." Eugene looked at him. "I don't know what that's called," he said. "I know what it does. If you hold a chain against saturated clay long enough without shocking it, the clay releases. It's like wringing out a wet cloth slowly instead of squeezing it hard once. The slow method gets more water out." Howell wrote something in his notebook. "Your grandfather taught you that?" Howell said. "He showed me," Eugene said. "He didn't have words for why it worked. He just knew it worked because he'd done it." The afternoon work took longer. The southeast lateral root was the largest of the 4, running approximately 38 feet from the trunk before tapering to a diameter of 6 inches and splitting into multiple smaller roots. Its main body, at 17 inches of diameter near the trunk junction, was the thickest single piece of root material in the entire root plate, and it had grown in a slight downward angle deeper than the others that meant the clay above it was thicker and heavier. Eugene spent 40 minutes adjusting the southeast rig's anchor point and rerouting the chain run to achieve a pulling angle that matched the root's downward trajectory more closely. This involved moving one of his anchor trees, not by moving the tree, obviously, but by extending the chain run with an additional section to shift the resultant force vector downward by approximately 15 degrees. Howell watched this adjustment with his notebook open and his pen motionless, understanding what was happening but impressed by the spatial reasoning that had produced the solution without trigonometry or CAD software. Eugene had done the geometry in his head, on the fly, based on what his eye could see and what his hands could feel in the chain tension. At 2:30 p.m., the southeast lateral separated from the soil in a long, progressive pull that took 11 minutes from start to finish. The root came out trailing a fan of smaller secondary roots that dragged soil with them, leaving an excavated trench approximately 4 feet deep and 3 feet wide along the root's path. When the last secondary root released from the clay, a clean, audible snap, followed by a brief settling of the soil surface, the clearing went quiet for a moment before anyone spoke. "That's the big one," Pete Salcedo said. "That's the big one," Eugene confirmed. The taproot came last, at 4:15 p.m. He had spent the previous hour and a half loosening the southwest lateral and, more importantly, working a single chain run directly under the center of the root ball, a maneuver that required him to drive a steel spade through the existing trench walls to create a channel for the chain. He worked in the trench himself for this part, on his knees in the clay at the bottom of a 3-foot excavation, feeding chain through the gap he had made with the spade, threading it blindly under the root ball by feel. His knees ached from the wet clay and from 75 years of accumulated use, and he did not remark on this to anyone. When the central chain was rigged and brought back to the tractor's drawbar through a redirect block at the surface, he had effectively created a lifting force component in addition to the horizontal pulling force of the lateral rigs. The 4-sheave system applied to the central chain, aimed slightly upward at an angle of approximately 25 degrees from horizontal, would generate a resultant force that combined outward pull with vertical lift, the combination that the root ball's geometry required. You could not pull a taproot straight out. The soil above it prevented that. But you could apply a force that simultaneously reduced the soil's downward pressure on the root and pulled the root laterally until it broke free. He built steam pressure back to 145 pounds per square inches. He had let it drop slightly during the rigging work, banking the firebox to hold temperature without burning excess coal, and engaged the clutch at 4/7. He held the full load for 8 minutes, watching the chain runs, listening to the frequency of their vibration, watching the ground surface around the base of the trunk for the first indication of movement. At 4:15, the taproot broke. It did not snap. It did not produce a dramatic single crack. It released, the way ice releases from a glass in warm water progressively, from one side and then the other, the clay above it fracturing in a series of small heaves that traveled outward from the trunk in a pattern that corresponded precisely to the directions from which the lateral chains had been pulling. The trunk itself moved, shifted perhaps 4 inches to the southeast, and then the entire root ball, perhaps 4 feet in diameter, and weighing what Renner would later estimate as somewhere between 6 and 8 tons, came free of the ground in a single coherent mass, trailing the broken ends of tertiary roots and dragging a curtain of wet Missouri clay. Dale Ferris had the Cat 330L's bucket positioned before the root ball finished moving. He worked quickly, quartering the freed mass into sections that could be loaded onto the waiting dump trucks, using the cutting edge of the bucket to separate the root sections from each other along the fracture lines that Eugene's pulling had already established. Eugene throttled the steam tractor down to idle and sat on the operator's platform, watching. The process had taken, from first pull to final separation, exactly 4 hours and 21 minutes. He had consumed approximately 600 pounds of coal and generated no equipment failures, no soil damage to the surrounding area, and no surprises. He climbed down from the platform and walked over to where Mike Renner was standing at the edge of the excavated area, looking into the hole where the root ball had been. The hole was perhaps 5 feet deep and 12 feet in diameter at its widest point, its walls showing the stratified clay and sandy loam of the Linn County subsoil, with the severed ends of the lateral roots visible in cross-section like the ends of pipes in a demolished wall. 4 hours and 20 minutes, Renner said. 21, Eugene said. Renner looked at him. Then, in the specific way that men who manage large projects acknowledge the moments when their assumptions have been entirely overturned, he said, "What would you have charged me 2 weeks ago before we spent 11 days on this?" "The same thing," Eugene said. Renner shook his head slowly. "That doesn't make sense." "It makes sense if you understand that my time isn't worth more just because yours got more valuable," Eugene said. $200 was what the job was worth to me. That hasn't changed. They drove the machine back to the granary that evening, arriving at dusk, and Eugene spent an hour cooling the boiler down, slowly opening the blowdown valve to reduce pressure in stages, not letting the metal cool unevenly, the same procedure he had followed every time he shut the machine down since his grandfather had taught him in 1941. When the pressure gauge read 0, he checked the water level in the gauge glass, added a small charge of coal to maintain a low fire that would keep the boiler from freezing in cold weather, and put the canvas covers over the flywheel and the cab. Then he sat on the running board of the granary door and drank a glass of sweet tea that his wife, Frances, had brought out, and watched the last light go out of the western sky. 2 weeks later, a letter arrived from Mid-States Construction's main office in St. Louis. It was addressed to Eugene Pratt and signed by Mike Renner. The letter said that Mid-States had 3 upcoming projects in north-central Missouri, 2 county road improvements and 1 state highway clearing contract that would involve significant stump removal work, and that the company was prepared to offer Eugene a consulting and equipment contract for the clearing phase of each project, at a rate substantially higher than the $200 he had charged for the Bur Oak. The letter closed with a sentence that was more personal than most business correspondence. "I've spoken to my engineering team about the mechanical principles you demonstrated on July 8th, and I want to say directly that what you showed us was not a trick or a novelty. It was the correct solution, applied with a level of precision that my professional engineers were not able to achieve. We'd like to work with you." Eugene read the letter twice, folded it, and put it in the tin box in the kitchen drawer where he kept important papers. Then he wrote back, by hand, on the same kind of ruled notepad he had used to keep farming records since the 1950s, accepting the offer and providing 2 conditions: that he would have full authority over the rigging method and approach for any stump or obstacle removal problem, and that his rate for any single day's work would include a half-day assessment period in which he would examine the problem before committing to a solution. He signed the letter Eugene W. Pratt, Linn County, Missouri. The 3 projects were completed between September of 1992 and the following spring. On each one, the case steam traction engine arrived on a flatbed trailer. The machine was too wide and too slow for the county road in most conditions, and Eugene rigged and pulled stumps and moved boulders and extracted buried concrete, footings with the same patient, methodical approach he had used on the Bur Oak. He was not always faster than modern equipment. On one project, a cluster of hedgeapple stumps in a sandy loam soil that offered little resistance. The Cat 320 on site cleared the area in an afternoon while Eugene was still setting anchors. But on the problems that mattered, the deep clay sites, the interlocked root systems, the obstacles that had defeated brute force, the old machine and the old method succeeded where the new ones had not. In the autumn of 1993, Renner recommended Eugene's services to a colleague managing a utility corridor project in Macon County. The recommendation spread through the small network of North Missouri road and utility contractors, in the way that practical knowledge travels in tight professional communities, not through advertising or brochures, but through the specific, respectful testimony of men who have watched a problem get solved. By the time Eugene Pratt retired from active work in 1996, at the age of 79, He had been hired for 11 separate projects by 6 different contractors, had operated the 1,912 case on more working days in the 1990s than in any previous decade of his ownership, and had generated more income from the machine than his grandfather had paid for it in 1,913 inches non-inflation-adjusted dollars. He made one specific observation to Mike Renner at the end of the third project they worked together, while they were standing beside the machine waiting for the flatbed trailer to back into position for loading. Renner had asked him whether he thought there was a market for what he did, whether younger men could learn the system and build a business around it. Eugene considered the question for what felt like a longer time than it deserved. "The method isn't the hard part," he said finally. "The method is physics. Any engineer can learn physics. The hard part is patience. The hard part is being willing to look at a problem for a long time before you touch it. Most people can't do that. They want to start pushing." He watched the trailer back up. "The machine doesn't make you patient. You have to bring the patience with you. The machine just rewards it." The case 1,912 was donated to the Missouri Agricultural Mechanical Museum in Chillicothe in 1998, 2 years after Eugene retired and 2 years before Francis Pratt passed away in the spring of 2000. Eugene himself lived until 2007, dying at 90 years old, of no single cause in particular, but simply of the gradual cessation of a body that had worked very hard for a very long time. The donation came with one condition, which the museum accepted in writing. The machine was to be maintained in running condition and fired and operated once per year at the museum's annual harvest demonstration, which it has been, without interruption, in every September since 1998. The museum's maintenance records show that the boiler has required no structural repairs in that time, only routine valve reseating and minor brickwork, and that the engine, once the flywheel is rotating and steam is distributed to the cylinders, runs at approximately 228 revolutions per minute under no load, which is within 3% of the manufacturer's specification from 1,912. The placard mounted beside the machine at the museum reads, J.I. Case Steam Traction Engine 80 HP, Serial No. 27,441, manufactured 1,912, Racine, Wisconsin. Owned and operated by the Pratt family of Linn County, Missouri, from 1913 to 1998. Used in active commercial stump removal and land clearing work through 1,996. Still capable of being started. And below that, in smaller text, a single sentence that a museum volunteer, a retired school teacher who had known Eugene Pratt slightly through the county fair demonstrations, had suggested, and that the museum director had approved without much deliberation. You can't beat physics with muscle. You have to work with physics, not against it. Linn Pratt, circa 1926. Each September, when the machine is fired up for the Harvest Festival, when the pressure gauge climbs from 0 to 135 pounds per square inches over the course of 90 minutes, and the flywheel begins to turn, and the first exhaust puff emerges from the stack, the crowd that gathers around it is not the same crowd that would have gathered in 1912 or in 1945 or in 1992. Most of them have never seen a steam engine in operation. Many of them are children who have grown up in a world where the idea of building a fire to make a machine move seems as distant as the idea of sailing across an ocean without GPS. But the sound is the same sound. The deep, unhurried chuffing, the smell of coal smoke and hot metal and steam condensing in the morning air. The tremor in the ground beneath the rear wheels, transmitted through 7 feet of diameter and 28,000 pounds of iron into the earth itself. Some things do not improve with replacement. Some things simply endure. In the summer of 2023, the highway maintenance crew responsible for State Route 11 inches Linn County resurfaced the section that passes through the area cleared in the summer of 1992. The foreman on the project, a 44-year-old man named Dale Ferris, the same Dale Ferris who had operated the Cat 330L 31 years earlier, noted in his daily log that the road surface had held its original grade, better than the sections to either side, which showed more subgrade settling. He attributed this to the quality of the original compaction work. He did not know, and the record did not tell him, that the drainage characteristics of the cleared zone had been substantially improved by Eugene Pratt's removal of the Bur Oak root ball, which had been channeling groundwater in a way that the highway engineers' as-built drainage plans had not accounted for. The root ball's absence had allowed the subsurface hydrology to normalize over the following decades, reducing frost heave cycling in the clay subsoil, which was why the pavement above it had lasted longer than expected. He noted it as a good result and moved on to the next section. Some legacies are invisible. They work quietly, beneath the surface, long after the hands that made them are gone.